Math 1332, Chapter 2, Set Theory, Section 2.1, Introduction to Set Theory, Video 1, Definitions of Set and Element. You may be wondering why the first video for this class starts with Chapter 2. This particular course does not go through the entire book that we are currently using. In fact, this course is designed to just sample various topics, not necessarily worrying about one topic leading into another topic, such as in a college algebra class, where all the topics seem to build upon each other. In this particular course, we'll be covering 4 chapters, starting with Chapter 2, and then following with Chapters 3, and then Chapters 7, and then a little bit of combination of Chapters 10 and 11. But we will be starting with Chapter 2 in the set about set theory. So let's start by just defining some basic terms, starting with the definition of a set. Now, if you look up the word set in the dictionary, you're going to find that it has a ton of definitions. And what I'm about to say might still be true, but at one point in time, the word set in the dictionary had the most number of definitions. But what are we going to use the word set as? Well, it's pretty straightforward. Mathematically speaking, a set is a well-defined collection of objects. Of course, what do I mean by well-defined? Well, let's take a look at examples of some things that are sets and some things that are not sets. So for example, we could say the set of all cars in the parking lot of Walmart. We could be more specific on, we'll say, Highway 64 in Tyler, Texas. And we could even be more specific. We could say at 7 p.m. on 5/17/21. So this is a well-defined set. Well, it's a set and it's well-defined because at that time, on that date, at that Walmart, we know which cars belong to this set. If the car is in the parking lot, then it belongs to the set. If it's not in the parking lot, then it doesn't belong to the set. Now, of course, we don't have to be that specific, but I wanted to do a really specific example for this first one. We could be do something a little less specific. For example, the set of all apples in a grocery store. Assuming that we know which grocery store we're talking about and what we know, what we mean by the word apple. Does that include apple juice? Does that include applesauce? No, just apples. But both of those are well defined, but here's an example of one that is not well defined. And I want you to ask yourself, why wouldn't this set be well defined? And then we'll clarify what that statement means. The set of all handsome men in a, we'll say on a football team. Now, why do you think this one is not well-defined? This is not a set. Because by definition, a set has to be well-defined. There's one word in here that makes it not well-defined. Which word do you think it is? If you were saying handsome, you would be correct. And the reason that makes it not well-defined is because who's handsome to one person might not be handsome to someone else. In other words, inclusion in the set is based on opinion, not fact. Again, that opinion is based on the word handsome. Sometimes you can actually have a set, or rather something that's not a set because it's not well defined, and it's not really based on opinion. For example, the set of all tall students in a classroom. This is not a set. Now, why is it not a set? Well, we all know what it means to be tall, but the word tall in this context is not well defined because who's tall to one person might not be tall to somebody else. For example, let's say that you're looking at me and I'm 5'10". If you are 6'5", then I am not tall to you. But if you are 4'9", then I'm probably tall to you. So the word tall here is not very well defined. Now, could we redefine this so that, or restate it so that it would be a set because it would be well defined? Yeah, we would just have to give a criteria for what we mean by tall. For example, we could say the set of all students 6 feet and taller in a classroom. Of course, this is assuming that we know which classroom we're talking about, but by setting a criteria, this is a set. By setting a criteria for what we mean by the word tall, instead of just saying the word tall, now we've made this well-defined and therefore we've made it a set. So again, a set is just a set of is a well-defined collection of objects, meaning that it is objective whether or not an object belongs to a set. For example, in that second one right here, we could walk into a grocery store, I could hold up an apple and you could say it belongs to that set. Or I could hold up a banana and you could say it does not belong to that set. Or if we were in a classroom and we were measuring how tall students were, if somebody was 6'1", they would belong in the set. If somebody like me were 5'10", they would not belong in the set. But it's clear and objective who belongs in a particular set. Now, what do we mean by element? Well, element is just a single object in a set. Now, I am not that good at typing, so you notice me correcting typos from time to time, but I like to type these as I'm doing the video so that you can have time to write them down as well. But an element is a single object in a set. For example, we could say that, what's a good example of an element in a set? Let's say that, okay, the letter A is an element of the set of vowels in the alphabet. Of course, I mean the alphabet that we use when we speak and write English. So if we had all the vowels in the alphabet in our hands, and the letter A would be inside of that set, it would be an element of that set. Or for example, we could say that Kareem Abdul-Jabbar, and forgive me if I misspelled Jabbar, is an element of the, told you I can't type, is an element of the set of all NBA players. Notice I didn't say current NBA players because he's not. And there's a lot of sets that he belongs to. He's a set of all NBA players. I believe he went to UCLA, so he'd be a set of UCLA alum. We could say that he's an element of the set of NBA players who have won championship rings. We could say that he's an element of the set of people who have played for the Los Angeles Lakers. But there's a lot of different sets that we could say he belongs to. Now, when we talk about being an element of a set, it's also the same, it's also a legit thing to talk about not being an element of a set. For example, Mr. Chapa, that would be me, is not an element of the set of all NBA players. Or I could say something like Mr. Chapa is a set, I'm not a set, is an element of the set of all people who have ever taken a tap dance class, because I did take one in college because it was fun. So the concept of a set and an element is really quite straightforward. Just to summarize, a set is a well-defined collection of objects. I believe I can highlight that if you give me 1 second. Highlight you, we want to do this, here we go. A set is a well-defined collection of objects. Excuse me, I'm so sorry. I'm trying to hold off that cough. That's what happens when you're recording. But anyway, a set is a well-defined collection of objects, with well-defined meaning that we can determine if an element belongs to a set or not objectively based on facts and not based on opinion. And an element is just a single object in a set. Very straightforward definitions.